So yeah, hi again, everyone. My name is David Branton. I'm a lead engineer at Candide Limited. We are a startup based out of the UK. We're also operating in South Africa, and we've got a kind of a mission to kind of allow people to reconnect with nature, to love plants. We're definitely in that realm of tech for good and wellness, and it's definitely a very interesting landscape to work in. I currently work with React Native, but the previous 10 years before that, I've been in native Android. And that's what I want to talk to you about today, is my experiences with specifically something close to my heart, supporting both Google's version of Android and non-Google Android. And what do I mean by non-Google Android? It's it doesn't exist, right, in a way. I mean all of the kind of versions of AOSP, Android Open Source Project, that are distributed onto mobile devices around the world that don't have things like Google Play services, well, not legally at least, and they don't have things like the GMS, the Google Messaging services, Google Mobile Services. The OHA, just to get through the acronyms, that is the Open Handset Alliance. We're probably very familiar with that owing to the recent discussions that Huawei have been having with Google. And essentially that's like a membership list of OEMs, original equipment manufacturers, that have agreed to build compatible versions of Android, so those which pass Google's compatibility test suite, ultimately. A few manufacturers, such as Amazon, have gone their own way. They did that a long time ago. So we're going to discuss a bit about Fire OS and how to support that. But to kind of navigate us through, well, why it might be something you want to consider, and just to provide a narrative, we're going to think about, is that going to work? No. Okay, I might have to resort to, oh no, it's alive, thank you. So we're going to think about two narratives. The first being, imagine we're in this scenario where we turned around one day and your product manager, or maybe just another member of the team, saying, why aren't we on the Amazon App Store? I hear there's a load of devices that have got that on. But perhaps also your marketing department have always looking to grow, and they've identified a whole series of users in a different country that may well benefit from the services that you're currently offering. So those two scenarios are somewhat made up, but they are reasonably real. But before we dive in and say, right, we're going to build our app so that we can publish onto the App Store, we can build our app so it's compatible with the Android Open Source Project, we need to consider quite a number of things. I've been talking with a number of you at the conference before, just the last few days, to get your impressions of where you stand with this. And I think the skepticism is a good place to start from. It doesn't make a lot of sense financially in some cases. It definitely costs money to support forks of Android. You're basically rebuilding a lot of what Google's already built for us by way of the Google Play services, and they make it really easy. The Google mobile services are constantly improving. In the 10 years that I was working with native Android, we went from GMS core to kind of the breaking down of that monolith into multiple different useful APIs, and the APIs kept getting better. They've been battle tested. So moving away from those into perhaps your homebrew ones or an alternative manufacturers, and actually coding that stuff twice, as we'll go into, is going to cost some money. But it might make sense depending on a few things. So we'll go into some of those. So what kind of devices or type of application you're building. So on the point of Amazon's Fire OS, that is primarily tablets. So if your app is a tablet-based application, or it benefits from being on a tablet, and I'm thinking media streaming, that's a prime use case of the larger screen, then you should start looking at things like Fire OS and other versions of Android. Yeah, where your app will run. As is widely reported, the Play services do not exist in some parts of the world, as in like you can try and hit those APIs, but they're blocked behind firewalls, such as in the case of China, or they have got problems in other parts of the world. I've recently was talking to a colleague of mine who's building a media streaming app in Iran, and all of a sudden one day it stopped working. And that's because they decided to block Google for about 4 months, so into problems in the country. And that kind of dynamic, when you're building for that next billion, as Google put it in many presentations, adds a degree of risk when you're using only Google services. And finally, ubiquity. I've worked at a large takeaway company in my prior Android career, and there's an interesting point. As our growth started to slow down, as we know, our acquisition wasn't doubling year on year, we started to look for like channel diversification, so moving into different, trying to get those last 20% of users, and they're spread around on multiple OSs, some of which include the OSs I've mentioned. And at this point, capturing that last 10-20% is actually just as important as retaining your users and keeping that growth metric high. So at some point, there is where the cost isn't so much as an object. You need to think about just getting more people into the start of your funnel in order to keep those acquisition metrics high. So I probably couldn't do this presentation without speaking specifically about Huawei. There's probably 3 main takeaways that I've kind of distilled from this from a developer standpoint. The first is that exposure point I just mentioned. Huawei, they shipped 250 million devices in the last quarter. Only half of them were running OHA compliant Android. The other half were running their own raw Android implementations. And if that future is that they may move away from Google's version of Android, or they have to leave the OHA, then all of a sudden there's going to be a lot of devices on the market, a lot of good devices. I imagine a number of you have this phone in your pocket right now, or the P20s, etc., which are very capable devices of running your apps, and you're going to want in on some of that shipment. So strategically, having your clients or apps only work on one operating system might not be the best idea in a growth perspective if these are turbulent times somewhat. Before I go on to that, and the last point, the Mate X device, the Huawei Mate X, that's one of the foldable phones. It's very innovative, the whole foldable device scene. I think there's a talk happening right now about it, and we're really proud of that as a community. We are happy to be pushing these operating systems as far as they can go. Who knows what the future holds for foldables? And Huawei have been quite innovative in this sector in general. So losing them from our kind of home ecosystem, if you like, that is quite a loss in some ways. So I wonder whether that would stifle some of the growth. And that growth is plain to see in this chart I've got right here. And I've highlighted the Huawei line. I just draw your attention to the final figure there. So their year-on-year increase in shipments has been over 50%. And another interesting aspect to this chart is that Huawei, Xiaomi, Vivo, Oppo, these are all Chinese manufacturers of devices. And a lot of their devices aren't running Google Android simply because it doesn't exist there. So bear that in mind if you're looking to justify that business case about where you want your app to run and what the potential user audience you may then gain. Okay, so if you decided that supporting multiple versions of Android or multiple operating systems is a good thing, so maybe you're a tablet media streaming app, you want to break into a new market such as China, you've got the money because your brand is established. I've kind of put together the 4Ds, somewhat contrived to make it 4Ds. It was 3Ds, and I made it work. The first being dependencies. So we're going to go into how to identify where you're using Play, and then how techniques you can use to not remove play from your code base. You're always going to be wanting to support the dominant player, the Google Android ecosystem, but how you can then append in a different flavor of your app alternative implementations. Second D, differentiators. I think this is quite a well-known myth of if you support Fire OS, you can't use parts of the Google system. I'm going to show that that's not true. So this is all about not going for the lowest common denominator. There's a history of when that's been the strategy, and I'm thinking like called over apps, etc. That hasn't worked out well. So building for the operating system that you're on, taking advantage of all those things that we've seen from Google of late, such as app bundles, etc. Deployments. So this has been a key point for why these ecosystems haven't been growing as well as perhaps they should, considering that most of our apps are compatible with them. We've got some great APIs, so I've built some tools to help you that you can take away today to show how you can publish your apps onto these stores in an automated way. And then finally, distributions. It's quite a quick section. We heard a lot, if you're in the community day, there's a panel discussion about the Play Store and the various app stores. We're going to recover some of that ground, and maybe I'll go into a bit more detail about how WeChat works. So first up, dependencies. And I mean those dependencies. I mean GMS. What we want out of this section is to kind of explain that your apps will work just fine without Google services. What you can see behind me is essentially one of my applications running with Google and then without Google. And that's kind of the behaviors we want to see. It's almost, you can't quite tell that there's a different mapping system being used. And that's kind of one of the main tenets of the approach I'll describe, is that you want it to be as good an experience as possible for your users. You don't want it to be no-opping or not showing a map or showing a static map. That's OpenStreetMap on the left-hand side, via OS Droid, if you've heard of that library. Of course, Google on the right-hand side. So how do I go about finding where I'm using GMS? This is actually harder than it seems. Lots of the libraries are used, particularly the analytics SDKs, implicitly pull in lots of licensing, GMS things, identification. And I've used two tools in my time for building for both Amazon's OS and Google's to help me keep play at bay, as it were. The first being DexCount by KeepSafe. I think you probably heard about that, and maybe some negative language regarding the additional build time it adds. This is something that will be running on your build servers, not on your local machines. And then just raw Gradle, where Gradle can help you find out who's using GMS. So the first one, DexCount. So this is the thing that's going to tell you how many methods you're using, how many classes you're using as you head towards that Dex limit or go way beyond it. But it also gives you this very pretty picture. So this is a visualization of all of the dependencies in your code base, and that big purple bar is me scrolling through it and finding where I'm using GMS in the Google flavor of my application. And this I find a really useful way, just a low brain power mode, saying, where am I using GMS? What parts of the Google mobile services am I using? And I love a graph. Oh, number. Thanks for that question. That's actually method count in this instance. It's the number of methods that have been added by a particular package. So you can see it going from, that's my app, the orange one, but the purple one, where the majority of Play services are. And that's a good point from whoever said that. It's you get a lot of methods by using GMS, so you can thin down your app quite considerably, which I'll come on to. And the second bit, using dependency insight. So if you probably all run the Gradle : dependencies command. Again, very pretty tree view, but not very useful. If you run the Android dependencies command, you actually get a list which you can then pipe through into Z or something like that to isolate which of the dependencies actually have these 3 letters in it, GMS. And yet, admittedly, it's not only GMS. Firebase also tend to rely on some Play services in parts, not always. We'll come on to that. So yeah, using dependency insight, specifying what dependency that you found that you want to isolate, how is that being pulled in, will give you a view that looks similar to that. And that allows you to take that huge tree and be quite focused about where bits of the Play services are being pulled in and which part of the Play service system or which part of your app is pulling in various Google products. Yeah, take a picture of that one. So, what have we got to consider? So, I talked about finding Play service libraries that have been pulled in. What do they mean? So, there's quite a lot of them, but these are the main groups. We've got mapping, geolocation, diffuse location provider. Some of the Firebase products, as I mentioned, these have got, most have got dependency on GMS. Some work even without Google Mobile Services. Neat things, as I've termed this, such as the open source software plugin. This is something that will just generate to you your license file. That's also behind things like GMS. I had this in. I gave this presentation at my local meetup not so long ago, about a year ago, and this was prior to Work Manager. And I left it in, actually, owing to the fact that it's kind of something that's not concerned me. I think the way in which we distribute Play means that our users get a better experience by virtue of having the best APIs and the most backwards compatible APIs. But I couldn't quite understand why the job scheduler APIs only made it into the Play services for about 9 months before Work Manager started alphaing into life. And I ended up using a third-party library called Evernote's Android Job. Very, very well put together library. But all kudos to Google there. They went over to Evernote in order to build out the Work Manager. Little known story there. But yeah, things are appearing in Play first, which is as opposed to AOSP, and they are making their way back to AOSP sometimes. This one, I couldn't quite make out why this thing was part of Play. And then development workflow changes. So as someone shouted out about the method counts there. When I first built for non-Google Android, we didn't have Play on the emulators. Well, we kind of do now, but not across all of the various form factors. So I've been using this actually to improve my kind of UI build, where I don't need to be compiling these big libraries every time I make a small change to my UI. Maybe I should be doing TDD. I don't know. But if I want to render a map and put a pin on it, it's much faster in some ways to just use a simpler implementation such as OpenStreetMap, and I can run it on the emulators. Okay, so they're the primary ones that you're probably using in your app. I don't think I've seen a single mobile app in my time building which hasn't just put in a map fragment of some description for fun, even if it's just a contact page. Interestingly, if you're using maps in a static context, then Google has a completely different API. Essentially, it's called the Static Maps API, and I wasn't aware of this, so I wanted to highlight it. You pass through a URL, you define where you want your points, your polylines, which your viewport, or the bounds of the map, and it'll send you back a PNG, which is really quite useful. And in lots of simple map cases, you don't need to be using map fragments. You can just hit this API, and your code gets simplified as a result. So that's one alternative if you're in a basic use case of a map. If you're in, obviously, a dynamic use case where you're dragging it around and you're moving things, then you're going to want to replace that with something like OpenStreetMap via a flavoring approach, which I'll come on to. Geolocation, don't use a Play service implementation if you're not relying on Google Play. By that, I mean the raw location APIs. True story, no GPS chip ever needs Google Play services. But yes, you do get a more accurate interpolated approach when you fuse Wi-Fi information from SSIDs and activity information, stuff like that, which comes via Play. But in most cases, just put a point on this map. I don't need it to be turn-by-turn accurate. Analytics, something we're using at Candide. Segment, very similar to GTM if you've been using those products. So we now report all our analytics into one place, and then that is Segment, which has its own APIs, independent, and then it has integrations into all of the providers. And if you're, as I was, in a position where I'm like, oh no, I've got to integrate another SDK because marketing had bought something else. These kind of providers are what you need to look at. They simplify that integration considerably and also improve the data quality, so it works both ways. And yeah, that neat things. Sometimes you have to write it yourself, so that's what we're going to do next. So I've got a toy example, slightly over-engineered, like most of my code. We're going to architect an application I'll go through some 4 tenets of architecting an application to remove play services from one flavor. So we're going to be using product flavors. That's the first kind of like tenant. And what you can see on the left-hand side is the licenses screen on one of my applications that run on Amazon's OS, so Fire OS. And on the right-hand side is, perhaps you're familiar, this is the Google OSS plugin. There it is. So yeah, first off, we're going to define a product flavor. So this is kind of like our backup for that, kind of reducing our exposure. We've got the with Google one, the apps we're building now, and we've got the without Google flavor. And notice that we're using the scoping of the dependencies to either rely upon something that includes GMS or something that just includes, well, com.brandapps is my namespace, so something else. And this is how it looks in a rough outline of the code. So you can see that we've got those 3 flavors, and each of them has got a manifest. And the second tenant is like manifest merging. And although I think we're all probably quite familiar with that, either through debugging or not, it's an important part of this of supporting multiple versions of Android. And the reason I want to highlight here is that a lot of the time, particularly when I've seen projects that have been highly modularized, the parent app still contains most of the information about the child modules. So what I wanted to highlight here is that the modules that you've identified as containing GMS, such as using tools such as Dependency Insight, they're the modules that should have a manifest which references either the Play Services version of the activity or library that you're using, or the one which doesn't. So move the activities that refer to a specific module or inside a module to that module, and you'll start to benefit from compiling out. Second bit I wanted to highlight is, or third tenet, I should say, is programming to an interface. And if I just think about this for a second, so this is thinking about the what and not the how. So what am I doing as opposed to how am I doing it? And the main benefit there is that we can, in this example, we're going to be building an intent. So I've just mean like a new intent, an intent. I want my mainline code not to care whether it's the play version or the non-play version. So that's where interfaces come involved and that whole paradigm of programming to an interface. So what does that look like? Very complicated interface. We've got a build method, and then we've got these 2 other functions here, which are responsible for building, laser, yes. The open source one from Google, and the non-Google implementation. And notice they're under the different flavors. So we've got an interface in the main code base. That's going to be in every single binary that we put together. But when we build the binary for Google, then we're going to have this code which references dependencies that perhaps don't exist in the other one. And then the 4th tenant is kind of the wiring it together. It's the dependency injection side. But notice one more thing about the way in which this is happening. We've got the com.example.app licenses and the com.example.app licenses, and they've got the same name. This isn't namespace overriding, so we're not in a bad place here. We are compiling based on the source set. So we're taking advantage of the fact that the mainline code can't tell the difference between the license module in the Google flavor and the license module in the non-Google flavor. by virtue of the fact they're in the same namespace with the same name. So we're not overriding anything here, but we are merging two things together, the source sets and the naming of a class. And those license modules abstract away which dependency that you actually want back. So obviously at this point you're thinking, where's my dagger, where's my Cohen? I've purposely not included those since they can tend to confuse things, but these are essentially factory methods to provide those dependencies. And then our mainline code starts to look a little bit like this. Maybe don't do it all in line. So we've got a preference activity, perhaps, and you've got a link off that to your licenses. And then when I click a button, maybe it's a row item on that preference activity, I'm going to go away and essentially build an intent that is able to either launch into the Google version of the licenses or into my version. And obviously the key point here, there's no mention of Google. I'm untethered. None of the imports in my class are going to be mentioning Google or Amazon or any other fork. All of that has been delegated either to the dependency injection aspect or to the flavor itself by source set compilation. So this technique, so the four tenets, manifest merging, moving the functionality that belongs to a module into its module configuration, the manifest. The second one, flavoring, initially. And the third one, programming to an interface, combined with dependency injection, allows you to do a lot more complicated things. So I said, this is a toy example. You could probably get away with an if statement for this one. So if Google, I'm going to launch that activity. If not, I'm not going to launch it. You might not get through a view when you actually distribute this to other app stores, since you're still using that in your mainline code. But you can extend those four tenets into far more complicated scenarios, such as the one I highlighted right at the start here, where I'm switching out entirely different mapping systems. So Google's map is a fragment, OpenStreetMap was a view. I call a function in my mainline code, just said add to view from fragments. I've also got a parent view that they can be added to. So you can keep extending this approach into, well, basically doing anything. I've done it with Job Scheduler. Don't need to do that anymore, since most of the Android X is fine to work on both operating systems. And yeah, that's the kind of that's our goal, is that our mainline code is uninterrupted. It still reads as if it should be, but our dependencies are determining what happens next. So second D, differentiators. So the differentiators that I'm talking about here are building for the platform. So the first thing that I've been struggling with of late, I haven't actually moved to app bundles until a week before this presentation, just to make sure everything was working okay. And I was put off moving there because I thought, right, this is a proprietary format, the AAB. This is not part of AOSP. It's a good thing, and that's undeniably true. Smaller app sizes are a good thing, but maybe I can get away with ABI splitting, et cetera, et cetera. And in my use case, actually, it's still very slim. I get like a 10% improvement according to the Google Play dashboard. But it's not, I can still use an AAB on my non-Google flavors and extract out the various actual installables. So another kind of, maybe because I didn't read the docs, but the AAB is just an upload format. It's not actually the installable. The installable is still an APK. So when you build your bundle, you can use the bundle tool to extract out a universal APK, which is probably what was being built in the older approach of building APKs. So first myth busting is that you can still use these new features of Google while supporting the older one. You don't have to drop down to the lowest denominator. Second bit, IAs. So again, in order to kind of prove this out to myself, I built an instant app in order to see how did that actually impair or improve the code in my app. And happy to report that although obviously this doesn't make any sense on operating systems such as Fire OS, they don't have this idea. Again, it's a proprietary Google thing. This isn't raw Android, as it were. You can still support IAs and dynamic feature modules, so assuming that you've moved to Android app bundles. I think the APK version of Instant App has just been deprecated. But this is still possible. It doesn't prohibit you from doing these things whilst you're supporting those other operating systems. And then if we specifically look at the Amazon side, they have their own suite of products. which look very much like GMS. They've got their own name for them, add-ons. So using those 4 tenants that we just ran through before, you can start to use either the mobile ads version of their APIs, etc. And one of the things with Amazon, as we'll move on to the next section, is that they're very similar looking by design. I'm not entirely sure if I know speaking with the Huawei team out there, they've got a HMS, so Huawei Mobile Services, coming. So if those APIs are getting too different, maybe this approach would fall down a little bit. But I think one of the kind of primary tenets of having a successful operating system is being able to gather users and gather developers. So I don't imagine digressing too much from what came first, which is Google's. So deployments. So this section is basically purely about how do I get my app out to the various app stores. And my experience has been primarily with Amazon's App Store, so that's what I'm going to talk about now. When we talk about distribution, the final D, we'll look at some of the different app stores that are out there. But the deployments approach, we've got the great Google APIs, but now, as of April, we have Amazon's publishing or submission APIs, as they refer to them. These APIs, again, as I just mentioned, are very similar to Google's. They have 99% similar functionality with V2 of the publishing APIs from Google. And to kind of help you guys along with that, I've got a small gift. Yes. Which is a plugin that I built, which allows you to essentially do the same thing as you might do with Fastlane. You can use this within Fastlane as a SH script, or things such as Triple T, great Google Play publisher. It essentially borrows a lot of the ideas from that, which allows you to essentially upload your Amazon version of the operating system to the Amazon App Store, and that's kind of what the API looks like. They've got a very similar thing with our P12 tokens that when we deploy to the Play Store. There's the JSON file, your application ID, and they refer to kind of like new app versions as edits. That's the only probably nomenclature difference. So if you're publishing to the Amazon App Store already, then look it up, and that's how you run it. And if you want to add some more functionality, currently it's focused primarily on the binaries, so just the binary upload, not the listing information. Feel free to PR me. Deployments, keep going with that a bit for these last 2 slides here. We've got probably this, when we're rolling out our apps on the Amazon's App Store from Fire OS, you got very similar to Google's V1 version of stage rollouts, so like fixed increments. So not quite as good there, but it's certainly improving. We've also got the ability to do like live testings that's similar to the alpha tracks and internal testing tracks. On the testing side, there's nothing stopping you using Google's tooling, Firebase's test lab for your non-Google flavors. I do that with my app. So I upload my non-Google one with OpenStreetMap. It runs the same tests, so there's no limits there. Amazon make integration with their device matrix. I forgot what it's called now. It's the Amazon device matrix or something or other. Very easy. I mean, it's an alternative to Firebase Test Lab. 6 of one, half a dozen of the other. And then finally, distribution. Get the time. Yeah. We are at the 4th D now. These are the popular app stores that aren't Google. And this has come up a few times in the conference. I like to highlight SlideMe. F-Droid we've heard about, and Aptoid we've also heard about. But SlideMe is actually pre-installed on a lot of devices in India as the primary app store. So getting onto these app stores, not many of them have APIs. It's more of a manual submission. And I would consider these 4 as kind of like being, I don't know if you went to the security presentation, they check a lot of the quality of the products being uploaded. But yes, it's true. It's a wild west out there of various other app stores once you've gone beyond those kind of 4 main ones there. Of varying quality too. WeChat, I cover that briefly. Completely different model. So if you are looking to go into that China market, we're talking about building your app not in native binaries like APKs, etc. We're talking about JavaScript, mini programs, and it's a completely different world. It's more akin to hot loading or co-push from Microsoft, where you can install apps. And their app store isn't so much real, it's just people share QR codes reverently. It's the primary way of sharing information. So people install apps simply by scanning a QR code, which is, I know we've all seen that flowchart. Should I use a QR code? No, not true in China. So to recap, first of all, if you've got a business case for supporting an Android fork, and there are a few reasons why that might be true: tablets, ubiquity, got the money, etc., or you just want access to those users that are behind non-Google Android, and there's many of them, then look at your dependencies, use tools such as DexCount and Gradle's dependency insight, techniques such as compiling out, which is that combination of Android manifest merging, flavoring, programming into an interface, and dependency injection in order to remove play from the flavors of your app that don't need it or can't use it. Don't worry about the differences. You can still build the best features for that particular operating system. So in Amazon's case, you can use their functionality for their replacements of all of GMS's things. You can use instant apps. You can use dynamic feature modules. Adds a few more complications, hence the cost step, but it's still definitely possible. Deployments. In Amazon's case alone, it's very easy. Use the plugin, build your own plugins. It'll be transparent, put it into your CI. This has really been holding back their App Store not having this API, in my opinion. But now they exist, that's a good thing. So we can ship to Amazon as if we were shipping to any other operating system. And finally, distribution. Take a look at some of those app stores and make your own decision as to whether that's the right thing for the market you're moving into. So as I mentioned, things like SlideMe, these are the OEMs are putting that onto the phone as the primary app store. So definitely do your research in that area to find out whether it's worthwhile going to more than one app store. Okay, I think I've just about covered that.